Okay, hello for everyone. I hope that you are excellent. So, welcome to the week number 3 in 11th grade computer science. So, we're gonna go to our classwork, in which I'm gonna publish the week number 3. So, remember before to do the other weeks. I'm gonna put available next time this classwork now. But anyway, we're gonna go to our class notebook. I have to say that in the class notebook you will have all the information about the topic that we're gonna watch this week. Yes, here in the class notebook you will find all the support material, all the things about that, and there you will find all the theory about with the practice that we're gonna do, right? So you have to keep in mind this. Okay, so now in accordance with this, we're gonna start. Okay, nice. So remember that the week number 3, we're gonna talk about analog digital signals, and also we're gonna talk about the sensors that we can use in our practices, right? So we're gonna go to unit number 3. In unit number 3, you will find this classboard, right? In the classboard, you will find all the theory about that. Okay, so here we talk about with the two types of electric signals. We have the analog signals that are signals that can have infinite values in an interval, can be of time or to voltage, right? So these different signals we can find in when we want to measure voltage, current, temperature, pressure, and distance. Yes, so I suggest you that check all the documentation that I am telling you here, and with that you will understand better the context of this video, right? Also here we have we talk about the analog signals, that we have different analog ports that we can recognize using the A letter. For example, A0, A1, A2, A3, A4, and A5 are analog inputs. Yes, so that means that we have 6 analog ports that we have to use only like input, right? And here also we are talking about a strategy that the microcontrollers have to convert analog signals, for example, voltage or current, in digital signals that the computer can understand. Yes, and inside of your Arduino you will find this circuit to convert these signals in PWM signals, right? Also, if you want more information about this, you have to access here, and that's it. Also, we're gonna build this this circuit in which we're gonna use the 3 LEDs that we've worked previously. Also, we're gonna work with this potentiometer and our Arduino Uno. Yes, remember that the potentiometer is a resistor that I can use this handle. Yes, I can change the value of the resistance, and with that I can control the current that flows through the circuit. Nice. Okay, so it's time to talk about the code, right? So we're gonna go to the Tinkercad. Remember that if you go to the class, to your class, yes, here I'm gonna put all the activities about that. You have to go to analog and digital signals, and next I'm gonna put. So in this activity you will find this circuit that we're gonna do, right? So I'm gonna go here and let's watch. Okay, so it's important that don't copy and paste just the circuit with an understanding. Suggestion: do it, type by yourselves, and with that you will understand better, right? So I'm gonna explain briefly the code. Yes, first of all, we have one input that can store the value that I am measuring in my potentiometer. Yes, first of all, I'm gonna determine what is this input. In my case is A0. This will be the port that I'm gonna use to measure the resistance in this part, right? So here in sensor output, this is the output that we're gonna use to control the brightness of our LEDs. Yes. So after this, we're gonna go to the setup function. That is the function that can initialize all the protocols that we are using in our code. So first, we're gonna establish our digital ports as outputs. Yes, remember, and don't forget to connect the LEDs in PWM ports. Why? Because we're gonna convert these analog signals that we're gonna produce with our potentiometer in digital signals, and we're gonna represent these signals through PWM, okay, through pulses. For that reason, it's important that you connect in the PWM ports, right? Also, another option that you can use it is to initialize our serial protocol if you want to watch the values that you are measuring in this circuit. All right. So once that we have all our variables, we're gonna continue. Okay, so first of all, with this command, sensor value is equals to analog read, and we're gonna put the analog input that, if you watch here, is A0 because it's the port that we are using to measure the potentiometer. We're gonna use this command analog read to read this value. Okay, so if you remember, the analog digital converter of our Arduino is of 8 bits. That means that we can have values to 0 to 1023. Yes, so we have to keep in mind this. Yes, so once that we have this, we know that our resolution of our PWM module is 8 bits. Sorry, in that case I confused. So remember that the ABC is of 10 bits, 10 bits resolution. That for that reason we can have values between 0 to 1023, and the PWM has values between 0 to 2255 because it's an 8 bits resolution module, right? So for that reason we have to convert this scale from values to 0 to 1023 to values to 0 to 255. Yes, so because we're gonna use this range of values to insert in our PWM module, right? So once that we have the values, we're gonna write these values in a command analog write. Yes, we're gonna put the PWM port and also the value between 0 to 255. Yes, and in accordance with this, we can have the brightness. 0, we have 0 if we don't have a voltage, and if we have all the voltage, we're gonna have 255. Right, so if you want to watch the voltage in the serial monitor, you can do it with this line and delay for 1 millisecond, because between reading and reading it's important that you leave a space of time. Right, so once that you have this, you can type in your Arduino, and let's continue with the next part. Okay, so now fast, we're gonna verify the circuit. We can use the previous circuit that we used in the first session. Remember to use your potentiometer. Remember that the potentiometer have 3 pins, right? So we're gonna connect these pins. Okay, so we have to use these cables. Remember, these jumpers that have these 2 extremes, male are very important. Don't forget that these are the types of cables. Okay, nice. So we're gonna start to connect. Okay, remember that our potentiometer have 3 pins. Okay, so you have to connect in the proto board with the 3 pins separated between them, like you are watching here, right? Now, so it's time to connect the 3 pins, right? So the pins that are between the extremes, you have to connect one of these pins, one extreme, to the positive. Yes, as you can watch here, we have to connect with the positive. So you have to ensure that the position of the cables and the potentiometer, that's nice for you, right? So we're gonna connect the first extreme to the positive. So it's very important that in this type of proto boards that you connect the positive and the negative in the same bus. than the leads, because if the protoboard is too large, maybe you will find two divisions, a division between two sides of the alimentation or the power supply bus, right? So for that reason, ensure that the positive and the negative of our potentiometer goes to the LEDs bus, right? So the positive we're gonna connect in this part, and the negative we're gonna connect at the same time, right? So once that we have this, we have to verify the connections. Remember, that has to be comfy. And once that you have the connections, we're gonna connect the other part, the half pin. So this pin we're gonna connect in the A0. Remember that is our analog input, right? So we have to search in our Arduino the A0, right? So we're gonna put the cables again. Remember, that has to be connected properly. Here we're gonna connect the positive and the negative, as I told you. Yes, this is very important. So because if you don't this, it's probable that you don't have a power supply in your potentiometer, right? So once that you have this, we're gonna connect the pin that is in the middle. So we're gonna do it. We're gonna search the A0 port, the A0 pin. In my case, you have to search. Remember, in your Arduino is very clear. The only thing that you have to do is to connect there. And so we're gonna search this A0. Okay, here is A0. Nice, this is A0, right? So finally, we have all our circuit complete, ready to program it. Look at the spaces and everything. It's nice here. Verify your connections and you are ready to continue with the programming, right? So now, once that you have your code by your own, remember to type by your own, so with that you will understand. Once that you have this, you have to go to your Arduino IDE. In your case, you have a more recent version, but anyway, any version is valid. Yes. So once that you are there, you will create a new file in which you're gonna put the code that we did previously. Important, if you want to learn, you have to type by your own, and with that you can ensure that you learn. Okay, so once that you have this, we have to connect our Arduino to the USB port. We have to verify that we have the correct board. In your case, it's Arduino Uno, and the port that the system will detect automatically. Once that you have these requirements, nice, it's time to upload. You have to click here in the arrow, upload. So you have to save your file. So you can put the name that you want. In my case, I'm gonna put ADC practice in the folder and in the file. You can put the name that you want. Nice. Okay, ADC practice. Okay, I'm gonna say yes. Nice. Okay, it's uploading, so we have to wait until it uploaded. The code is uploaded. So we're gonna do, and once that we are sure about that, finally here we have our result. Watch carefully.